draw a picture, and since we're working in bearing, let's set it up in terms of northeast, south, and west. All right, we know that north is 0 degrees, east is 90, 180, and 270, because we're working on our bearing form at the beginning. All right, now I'm just going to kind of talk you through. You're going to help me with this. We got two forces. We got a raft and we got an ocean current. So we're going to draw two vectors. The first vector we're going to draw is the raft. It has a bearing of 100 degrees. Show me with your arm where 100 degrees is. In terms of bearing, not in terms of unit circle. Very good. It's right down here, right a little bit below 90. So let's go ahead and draw in that vector, 100 degrees right below it. And we know that the speed or the magnitude is 10 knots. And this is our raft. The second part, the second vector we have is the current. And it doesn't give us a bearing, but it tells us it's going northeast. Show me where northeast is. Okay, now if you ever see this word on an assessment or even in a project, this means it's right in the middle between north and east. Directly in the middle. So we're going to split north and east right down the middle. And we're going to make this vector a little bit shorter because the magnitude is only 6 knots compared to 10. 6 knots. And what I'm going to do, or what's the degree measure going to be on that?
45.
Yeah, in terms of your bearing. So this is our bearing measure is 45 because it's right in between north and east. And then the bearing measure down here is 100. Now your project makes you do this. And here's kind of like something to be so aware of. Your calculator doesn't read things in bearing mode. The moment you go to your calculator to start inputting in degrees, what mode do you need to be in? Standard mode, or you need to be in the unit circle where this is 0, right? So you need to convert both of these numbers from bearing to standard position. So I'm going to give you guys a minute with your group. Figure out both of these in terms of your standard position. What degrees is it on the unit circle? Talk to your team about it. 45, I'm going to actually write it in a different color so you can see it. So that's our standard position. Raphael, what about this 100? This is not 100 on the unit circle. What is it on the unit circle? Any thoughts on this? Like Leslie? How did you get 350?
Because where 90 is, it's also 0 and 360, so you know you're going back 10, so you subtract 360 minus 10.
Yeah, how much are we going back here? 10, negative 10, between 90 and 100. So we can get negative 10, or we could do 360 minus 10 and go this way and get 350. Now here's the nice thing about this. We can just leave it as negative 10. It's a smaller number, and we'll get the same answer. So I'm just going to leave it as negative 10. Questions on how to get this negative 10 here? Yeah, Raphael? 2. All right, let's look at both of them. So here's our first one. We're going to first look at the raft. Now, if we look at the raft, it'll help to draw it out again. Here's your raft. It's on this path. It's traveling 10 knots. You need to figure out the component form of these two. Actually, you know what? I think I drew this wrong. Let me draw it this way. Make it x then y. So this is 10. And then my angle here is negative 10 degrees. So this is just this vector. I'm just redrawing it. You guys can do this. Figure out the component form of the raft using this magnitude and this angle. Take a minute or so with your team. Now we're going to look at our current. And it'll help to draw a picture again if you can, so you can visualize it. And we know this is 6 now, and we know this is 45. All right, I'll let you guys figure out the component form for this one. Are the x and y components the same?
Yes.
Why are they the same? 45-degree triangle, right? All right, so here's your second component. Should make sense. We're going right and then up. Here are your two components. Now the whole question is what is the actual speed and bearing of the raft? I mean, if we physically think about what's happening, if the raft is headed on this bearing, going 10 knots, and then there's a current pushing it this way, is it going to affect the final speed and direction of the boat? Yeah. Summer. Yeah, exactly. You're going to combine them. You guys know how to add vectors, right?
Yeah.
Go ahead, add your vectors. And we can call this our resultant vector. So this is kind of like part 3. Box this resultant vector, 14 and 2.5. Now, this is helpful, but it doesn't really give us the answer because we're looking for the actual speed and bearing of the raft. This is just my components, my x and my y. How am I going to use this to now find speed and bearing? Yep. Let's draw a triangle because it's going to help us see what's happening. So for this last part, I don't have much room, but I'll draw it in the lower right. Go ahead, draw your right triangle. And you know, I'm going to make it a little bit more to scale. And we know that my bottom length is 14, and I know that my height is 2.5. Why don't you guys go ahead and use this to find your speed and your bearing. You have the tools for that. I'm going to be hands-off, so see if you guys can talk about this. 14.2, Pythagorean theorem. That's your magnitude, that's your speed. Now, we need to figure out our theta, which is going to be this angle. A couple ways to do this. Some of you guys use law of sines. Is there another way to approach it?
Yeah, SOHCAHTOA.
Yeah, you could use SOHCAHTOA, tangent, or sine, or cosine. Originally, if you use tangent. Okay. That's probably the one you're most familiar with. So we have tan of theta equals 2.5 over 14. How do we get rid of the tan? Tan inverse, tan inverse. And I think you guys get what, 10.1?
Yes.
All right. So this is great. This is your standard angle, and you're going to be in standard mode the whole time you're using your calculator. But on your project, at the very end of it, I'm going to want you to go back into bearing, right? So if this is 10.1, and let's actually draw this out. Well, it's 10.1 here. How could I figure out the distance between 0 and that number? What am I going to do?
You add to 90 and you subtract it from 180 because all of the angles have to equal 180.
Okay, that's one approach. A little bit simpler way to look at it, yeah?
You subtract 10.1 from 90.
Yeah, because if this whole thing is 90 right here, right? If we take 10.1 out, we'll be left with this part, which is 79.9. So our final answer would be 14.2 knots at 79.9 degree bearing. And I want you to draw this because when you physically see it, it makes a lot of sense. So 79.9 degrees, show me where that is in terms of bearing. It's right about here, right? A little bit above 90. So, and it's a magnitude of 14, so it's longer. Let's go ahead and draw this last vector in. And this is our final vector. 79.9 degrees, and it's 14.2 knots.